Hello, everybody. My name is Chad Jennings, and welcome back to another episode of Beyond the Blueprints. And I am joined today by Sagar Chikkala, who's the CIO of FlexiVan. And today we're going to tell the story of how data and AI helps coffee cups and all sorts of other goods get from one place to another. So manufacturing through shipping containers, and FlexiVan comes into play once a container on a container ship gets unloaded in a port and then distributed. So, Sagar, welcome. I'm really pleased to have you and to tell this story. Can you please introduce yourself real quick and what FlexiVan does in this supply chain?
Thanks, John. It's great to be here. I'm Sagar Chikkala. I'm the CIO for FlexiVan. As Chad explained, let's start with the coffee cup journey, right? So even though it's manufactured somewhere in Asia, it packed into containers of thousands of other goods, loaded to a vessel at the Asia port, and travel across the ocean, thousands of miles, finally arriving like Seattle, right? Once it arrives at Seattle, that's where the customer has to move the container to the warehouse. But container doesn't have a wheels. So that's where FlexiVan comes into picture. FlexiVan provides the chances to pick up the container and move into the warehouse, right? And FlexiVan is one of the critical backbones of the supply chain. We actually provide the technologically enabled chassis. We bring the intelligence to innovation to the chassis space.
So, here's an image of the port of Seattle, and Sagar, you're going to run us through like how the containers move, but I wanted to point out a couple things about the scale of stuff here. So obviously there's a big ship in this image, and the cranes here are towering over the ship. And I wanted to call everybody's attention to this building that's in between the bow of the ship and the orange cranes. That's actually the Starbucks World Headquarters, and it's a 12-story building to the top of that clock tower. It's about 200 feet tall, and these cranes tower over it. So like the scale that Sagar is operating at is physically massive. Sagar, walk us through what happens and where FlexiVan comes in.
Can you imagine looking at the picture, right? The ship is carrying so many containers. Can you guess how many containers that can be? Actually, it can be 20,000, up to 20,000 containers it can be on a ship. So when ship arrives, you have multiple cranes working to discharge all these containers. That's where the real story begins because the container is in the terminal for pickup.
So here's a top-down view of the image we just saw. It's a different ship, but you can see the cranes unloading. And to get a sense of the scale here, each of these containers is, a semi-trailer.
Yes. So the containers, as you see, there are so many containers, right? We're talking about like a ship can contain 20,000 containers on a ship. So now the container has been discharged and available at the port. Now the customer wants a container to move to the warehouse. So the customer orders the trucker to pick up the container. But the trucker needs a chassis. So the trucker, as you see in the video, they come to the chassis depot, they pick up the chassis from the depot and go to the port. As you see, the depots are very near to the ports. And they travel, you can see the picture of the chassis, right? The chassis is just, with the wheels. Then they go to the terminal. As you see, the container is being placed on the chassis. Once the container is placed on the chassis, the trucker pick up the container, then taking into the warehouse. Sometimes they might not go to the warehouse directly because of the appointment constraints. In between, they might walk in the truck yard and then later from truck yard to the warehouse.
So, Sagar, we've gone through how the container gets off the ship and then onto a chassis, but there's still a lot of movement to do. Can you explain to us a little bit about like what's the path of that cargo once it gets off the ship? And it just so happens that we have a handy image to help.
Excellent. So as we see the flow, now the container is at the port, right? And the trucker picks up the chassis as we've seen in the video. They go to the terminal, then they're picking up the container. So when they pick up the container, there is a transaction that happened recorded by human being that the content has been picked up. Then it moves to the next location. It could be a truck yard or it could be a warehouse location. So one of the important part is the last mile visibility. The minute the trucker pick up the container, it lost the visibility because there is no other transaction happens. The truck yard typically don't track movement.
So it's the movement tracking that's the problem here. A customer can't see where their cargo is anymore. So how does FlexiVan solve that one?
That's a great question, right? And we started with a company, American Intermodal, in 2016. We come up with a concept called smart chassis. So we introduced the telematics on the chassis. So we have a hub, IoT hub, with the many sensors on the chassis. A sensor for the GPS. You have a sensor for the weight sensor, which actually tells what is the weight of the container. It's very useful because when the container is unloaded, it needs to notify the trucker. So it actually tells us, is it empty or full? And we also have a mount sensor, which is very important because we need to know when a container is placed on the chassis to actually tell it is mounted. So we actually construct all these events and builds the network story and provides the network insights to the customer.
So the amount of sensors on your IoT device is actually pretty impressive. And as we were prepping this, you said that the battery life, can be a number of years, enabling a very continuous stream of location, weight on wheels, data, etc. But what does that unlock for the customer? What does the customer see in this image, in this map that we've got up on the screen?
That's a great question. Right? So as the chassis have all the sensors, we collect the data of the sensors. It's the location, the state, and the whether it's a empty or load. So we are actually building the overall network insights. That's what we're actually presenting to the customers. They can see in real time visibility where the particular chassis is across the port, yard, or warehouse. They can even see where are the delays, how long it is dwelling at a particular location, where is the choking points in their network. So it actually provides the proactive monitoring, right? So it saves, a lot of per diem days. If they act correctly, it can actually save millions because a 1 day improvement in the network can actually save a lot of millions for the customers.
You mentioned prediction. Um, One of the other things that prediction helps with is, hey, this chassis has driven a whole bunch of miles in the last year. It might be time for maintenance. So, like, how do you predict when things are going to come up for maintenance?
Yeah, that's a very important question because for any asset-based company, right, the main cost component is the maintenance and repairs. So for a chassis, maintenance and repairs, it's very important to understand. We use our technology because we have GPS in the chassis. We even check the routes, how the chassis is traveling, which locations, which routes, patterns is causing the more maintenance costs. And we even use machine learning algorithm to predict the M&R based on the mileage and based on the time too.
That makes complete sense, and I'm sure your customers appreciate that. The aviation industry does the same thing with aircraft. It says, you know what, this one's approaching its maintenance limit, this number of hours, bring it in. It makes perfect sense that you should do that with these chassis, because if they break, right, then elements of the supply chain break down.
That's good.
When you start talking about like reliability, which is what you're designing into your system, um, we're talking about reliability for both the hardware and the software. So what were the design principles and requirements that you all employed when you were designing the FlexiVan data infrastructure?
Yeah, as you see in the supply chain, the data points are very important. There's so much of data points everywhere coming from many, many sources. So the integration was very critical. We had to unify the B2B data, API data, IoT data into the integration engine, right? So that data reliability is very, very important because the decision depending on accuracy and timeliness. We also have to support multiple partner channels, including EDI and API, and even a traditional mode of CSV data formats.
Mhm.
And there's no compromise on security and governance and customer flexibility.
Gotcha. Well, let's go ahead and get into the architecture itself. And, maybe you can walk us through, like, this architecture goes from bottom to top. Um, so maybe you can walk us through how the different elements of the system collaborate.
That's great. As we just discussed about the data part, right? We get it data from our facilities. It can be ports, it can be rail yards, it can be container yards, it can be warehouses, right? There's a lot of data we get it.
Mhm.
These are the transactional data, most of them recorded by human beings. And the second layer is IoT sensors. We have sensors sending the data every 3 to 5 minutes. We have to collect all the sensor data, millions of events we get every day. And we have the data talking about the bookings, bills, and the manifest from customers. And even we have the data from the truckers telling about what truckers did and all. So we gather all these data events, augmenting the transactional data to the sensor data through the integration engine. We use web method, which orchestrates
Mhm.
all the data pipelines, and we process all this data through the web methods, and we build the data layer, operational data layer, as well as the analytics layer.
And the analytics, so what infrastructure is all this running on?
We are running 100% on AWS.
Gotcha. Okay. So, like, this flow makes a ton of sense. You mentioned a whole variety of different inputs, from the IoT, from the truckers, from the customers. As we were prepping this, you even mentioned that there are cameras in the ports that you use to help identify the containers, so you can actually track when a specific container left the port.
Yeah.
It makes total sense that you'd use web methods to integrate all the data from those various sources. Can you tell me a little bit about the operational DB and analytics layer then?
Yes. So one of the important part, and we talk about transaction data, we talk about the sensor data,
Hmm.
but we also use heavily the Postgres. I think the reason we use Postgres is it is excellent database providing the geospatial libraries, right?
Hmm.
So we choose the Postgres. We build geofences across the years. We almost have 20,000 geofences of the customer facilities, the ports, all these locations. Once you have the geofences, once you have the GPS, we can build and derive the events. When it's entering the geofence, when it's exiting the geofence,
Okay.
how long it is dwelling in the geofence. Then we get all this data. Then we are building the complete, we call it trip DB layer, right? Because it's building the complete trip end-to-end supply chain trip DB layer. And we build analytics on top of that. That is where we are providing the visibility and insights to the customer.
Makes sense. And then, like, just to go back a little bit, this is the slide we were talking about before. So this is one of the UIs that your customers are like, and these blue lines here denote the various geofences, right?
Yes, yes,
So
that's
okay, so like the GPS is on the chassis, and when it leaves or enters one of these regions, you can say, oh, okay, it's left region A and move to region B. And okay, Sagar, that makes complete sense about how these geofences tie into, like, the locations and how you use that to track things that move along. But obviously, security and accuracy are critically important here. So, where do things break down in the real world when you're moving from theoretical to actual practice?
That's a great question. We always have challenges about missing data. The data indicators are very, very important as well as the security, right? So we get inaccurate data, incomplete data. So how do we solve this problem? Because when a cargo arrived at Seattle, if we do not know that container has been picked up, then the customer might not know where the container is coming to, when it's coming, where it's going. So it creates a gap in visibility. It makes it difficult to track the container as well as making decisions. So that's where we design the system to detect these gaps and flag them as exceptions. So we build exception management to resolve these exceptions. But as you see all this data coming through the integration engine, which is actually like a nervous system to the whole ecosystem, it plays a very critical role. It brings it the security, observability as part of the product. So it's a perfect layer for the whole ecosystem.
Gotcha. Yeah, it's funny, like, as everybody as the world moves towards AI and, Gen AI continues this buzz, if you don't have the right data in the system integrated properly, deduplicated, gaps filled and whatnot, then the A then what you get out of AI is just not very useful. Why don't we transition and talk about that now that we've covered the integrity of the data? Um, so how do you connect yeah, how do you connect the physical world to the data? We talked about the cameras a little bit already.
Yes. One of the important part is we talk about the containers moving, right? Um, and we are building the sensors. That from the sensors, we are building the insights. But one of the important is the container on top of the chassis we know, but which container actually is connected to the chassis is very important. If we do not know the container ID, we cannot connect the cargo. We cannot tell the story of the whole cargo. So that's actually we use AI vision. We actually use YOLO models from a camera feed to the ports. It actually derives what container ID connected to chassis ID and which trucker actually is pulling that one. As you can see, this is just a one of the engine that is taking the video and deriving, as you can see, chassis ID, container ID just from the video. It's very fascinating because YOLO models are very perfect and we get almost 95% of the success rate.
So let's transition. So that's awesome. Let's transition to how customers use all that data. So this is an example of a UI. We've got the GPS data, all the stuff that you've integrated through web methods. We've got the container IDs that you just showed us how you pull that off the camera data. How do customers actually use that when they're looking at this UI?
So the customers actually is getting the real-time visibility, right? As you can see the network insights, their assets, they can track the movements, they can access analytics in real time. They can even see the utilization insights. How many assets actually not being used? They can actually see how many assets are dwelling at a truck yard and they're missing opportunity to return and saving the per diem, right? As you see this UI, we even added AI layer to provide insights to the customers.
Gotcha. So the AI layer will help interpret the data, highlight issues, like we've got a blockage of chassis over here. Like, what kind of stuff does the AI help to highlight?
So we actually use AI heavily at a FlexiVan. It actually acts as a data analyst, right? It process all the events, identify the patterns. It can even provide actionable insights to a customer.
Gotcha. That's really, really interesting how you've taken, like, geospatial information, put it out here on a map, and then delivered, tracking analytics to customers who are trying to make sure that their coffee cups get from point A to point B in time. Um, what were some of the lessons that you learned along the way in building this real world system?
Yes, technology, is one thing, and adoption is another thing, right? Um, Even though we have so much of technology, we still have the vendors, customers still following the old methods of communication, data communication. So from that point, we have to provide all different channels, whether it's a FTP, still FTP, or API, or or all other new technologies. So it was a challenging. So actually, that's where the web method really helped to accommodate all different channels, right? The other important thing we faced is when we talk about any sensors, the power management is very important because sensors, when we install in a chassis, we aim to last for many years. But the more frequent things we get it, the more it feeds, obviously it consumes, the more power. So we have to manage the power very carefully because to install the unit again, it's very difficult because it's continuously moving. So it's very, difficult to install the unit. That is another challenge we face on the power management. That is where when the unit is not moving, we do not get the ping. We don't need to, right? Because we need to have the events only when it's moving.
It's many of the people who watch this are going to be in the data analytics space and less in the real world hardware space. So I appreciate you, bringing us back to some like real things like current and battery, um, and power management. So looking ahead, what's next for FlexiVan in your development?
So we are very heavy into our AI journey. As we see, we have been using AI vision. We are even have our own Flexi GPT, multi-model Gen AI capabilities for our employees. So we use that heavily for efficiency, right? People ask the question is like, hey, AI, what AI can do? AI can actually increase the efficiency. We can achieve our 5-year vision in 3 years, right? More efficiency, actually, we can achieve more. Another area we are investing heavily is agents, right? That's where our dream is to have the agentic logistics. We have the agents to fill the gap of exceptions. It can actually go to the different facilities and capture the missing data and it fill the missing data and complete the picture. We have the analyst agents where it actually provides the insights automatically. It's a dynamic insights. We have the enterprise intelligence agent for our internal employees. They can actually use the natural languaging against the database. They don't need to query. They don't need to talk to,
You don't have to
asking the
learn. You
IT
don't have to
to.
learn SQL anymore.
Exactly. Same thing in the new UI for our portal. We introduced the AI natural language enabled querying. Customer can query, hey, how it's doing, where is my asset? They don't need to click on the UI, right? They can actually generate their own UI dynamically. So our goal is really to autonomize logistics, maybe in future.
Excellent. Excellent. Well, Sagar, thank very much for the work that you're doing that helps our coffee cups get to where they're going without delays. This has been really fantastic. I very much enjoy data analytics that has to do with the real world. So I love the geospatial aspect here. And it's been a great example of how data integration is necessary to power those AI user journeys. So thank you very much for your work and thanks very much for joining us.
Thanks, Chad. Thank you.